Okay, Assalamualaikum and good afternoon. Now I have 28 students. 2 more students are missing. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
Betul.
Okay. Two are missing. One ada one. One. Okay, ada. Tan, you ada. Pradip ada. Syamimi ada. Haziq ada. Haziq ada. Hafiz ada. Fadli ada. Anas ada. Seri ada. Seri.
Ada.
Okay. Ada nah. Two are missing. One more. One is missing. Okay, let us continue. Present now, entire. Okay, now we have enough 30 students. Okay. Sekejap Cepat ni, slow lah. Okay, saya dah masuk balik. Nampak tak? Nampak tak slide?
Tak, doktor. Belum nampak.
Tak nampak lagi? Alamak. Sekejap Itulah komputer ni bengong ni. Komputer lama. Present now. Tadi station masuk balik semula sekejap. Dah nampak belum? Ni nampak tak? Nampak dah? So we have finished up to comparator. If I dah buka dah, nampak tak? Nampak tak? Tak ada slide.
Tak nampak.
Doktor
Tak
tak
nampak.
present
Doktor
apa-apa.
tak share.
Awak tak nampak?
Doktor tak share lagi.
Doktor tak present apa-apa.
Sekejap patutnya boleh ni. Nampak tak ini? Baik. Ini pun tak nampak? Present, tak nampak? Dia tengah loading ni, nampak? Tak nampak lagi? Macam mana nak buat ni? Menyampur betul lah. Tak nampak lagi? Okay, sekejap Okay. Dah nampak dah? Okay. Okay, ni nampak tak? Tulis function. Nampak dah? Aduh. Okay. Okay, nampak dah Okay, half adder, full adder, half adder we have done. On Monday, and you have done the lab yesterday. Full adder finish. Okay, full adder finish. This one we have finished this one. Okay. Alamak, slow pula. Okay, now we start with comparator. Okay, the function of a comparator is to compare the magnitudes of two binary numbers to determine the relationship between them. So in the simplest form, a comparator can test for equality using exclusive NOR gate. So you can see in this diagram, okay, this is exclusive NOR because you have bubble in front here. So how could you test two 4-bit numbers for equality? Okay, now and the outputs. of 4 exclusive NOR gates. So you have here exclusive NOR gate because this is for 4 bits, yeah. So you have 4 exclusive NOR, and then you AND all this the output from the exclusive NOR. You AND using the AND gate here. So you compare between the A and the B. So here you have A1, B1, A2, B2, A3, B3, and A4, B4. So the most significant bit is on B4. The least significant bit is on A1. And then if using the IC, you can see this is the type of IC for magnitude comparator. IC comparators provide outputs to indicate which of the number is larger or if they are equal. The bits are numbered starting from 0, okay, rather than 1. It's not from 1, it's from 0, as in the case of others. So cascading inputs are provided to expand the comparator to larger numbers. Okay, this is 4 bits. So you have here A, input for A, and here input for the B. Okay, you label it yourself. It's up to you whether you want to label this is X or Y. It's up to you. But here, example here, you label as A and B. So A0, A1, A2, A3. Here B0, B1, B2, and B3. Here is the cascading inputs. Okay, so this comparator to compare the magnitude, okay, between A and B. So if A greater than B, so you get the output here high. If A is equal to B, so you get the output here high. If A is less than B, so output here will be high. Okay, so if you need more than 4 inputs, 4 bit, here you have 4 bits only, right? If you need to design, let's say you need to design for 8 bits, then you have to use another IC, meaning you need to use 2 ICs. So here is the cascading input. So you will connect this to the cascading input of the other IC, and then you take the output. Okay, so the IC shown here is 74LS85. Okay, this is comparison for 2-bit magnitude comparators. Yeah? Okay, so here between A and B, let's see the input for A and B here. So here is 0, 0. B also 0, 0. So when you compare this, this is equal, right? So you get A equal to B equal to 1. Okay, now 0, 0 and B is 0, 1. So which is greater? B is greater than 1. So B, you get 1. And then next one, still A is 0, 0, and then B is 1, 0. B is greater, so B is greater, you get 1 here. And then here B is 1, 1, of course is greater than A here because A is 0, 0. So you get here 1 because B is greater. Now look at here, 0, 1. And then you compare with B, 0, 0. Meaning A is greater, right? So A is greater, so A equal to 1. And then the next one, this is equal, you get here 1. Here is 0, 1 and 1, 0. Which is greater? B is greater, so you get here 1 and so on. Until 1, 1 here and 1, 1 here. So A equal to B, 1. So using this truth table, you can design the circuit. So now you take out your pen and pencil. Okay, sorry, pen, pencil and paper. You draw the K-map. Okay, K-map for A greater than B, and then K-map A equal to B, and then another K-map A less than B. Do it now. Mana dia? Can you do it now? Shamimi? Draw the K-map for A greater than B, A equal to B, A less than B. And then do the grouping. Yes, you need 3 K-map. 3 K-map. Okay, one is A greater than B, and then another one A equal to B, and then another one A less than B. Have you finished? Okay, now you can check. Okay, this is the first K-map. A greater than B. You get the same equation or expression for A greater than B. So you have here one group is here. Okay, you get here A and then B bar, right? And then you have another group here that is A naught and B1 bar, B naught bar. Okay, and then you have another group here, here, this side to this side. So you have A1, A0, A1 and B0 bar. Okay? Mama Anas ada? Mama Anas?
Ada Ustaz.
Dapat tak? Anas?
Dapat.
Okay. And then for A equal to B. This is the K-map for A equal to B. So you see here you cannot do any grouping. So all in one here. Okay. You cannot do any grouping. So you get here A0 bar, A1 bar, B0 bar, B1 bar. And then here you have A0, A1 bar, and then you have B0 and then B0 bar, B1 bar. And then you have another one here that is A0, A1 to B0, B1. And the last one you have here A0 bar, A1, B0 bar, and then B1. Okay, so all in full expression you have here. And then for the last one that is A less than B. Okay, so you can have one group here. Okay, one group here that is A1 bar and B1 bar, and then one group here at the bottom here with the top here. Okay, that one you have A0 bar and B0 B1. And the last one you can do the grouping here. That is A0 bar, A1 bar, and then you have B0 1. B0. Okay. Okay, from this expression, then you can draw the circuit. Okay, so this is the circuit. Okay, do you have any question? Aziz, do you have any question, Aziz? Aziz?
No.
No.
Question.
Aziz dua-dua lah, ada dua Aziz kan?
Ya doktor.
No,
Okay.
Doctor, no.
Okay, so you can draw the circuit. This is like for 2 bits, so it's easy. The circuit is not very complex. Okay, now this is comparator. If you use the IC, so IC comparators can be expanded using the cascading inputs as shown. The lowest order comparator has a high on the A equal to B input. Okay, so this is, you see here, this is part for the least significant bit. So here is the most significant bit. Now this is for 8 bit. So the most significant bit here is A7. Okay, and then A4 here, and then A3 start here, and then A0 here. So the output here is connected to the input here, and this is you obtain the output at this port here. Okay, so if you need to design for, let's say 16 bit, so you need another 2 of these ICs. Okay, so you just connect. Okay, now finish about comparator. Now we look at decoder. Okay, so a decoder is a logic circuit that detects the presence of a specific combination of bits at its input. So two simple decoder that detects the presence of the binary code, that is 0011 are shown. Okay, so the first has an active high output. Okay, the second has an active low output. Okay, so now you look at here. This is the active high decoder. Look at these two circuit. What are the difference that you can see? What is the difference?
Satu and logic,
Okay,
lepas tu lagi satu
and
non-logic.
The first one is using the AND gate. The second diagram you have here, NAND gate, you have bubble. So here is active high decoder. This is active high output. Okay, you don't have bubble. Whereas here you have the bubble. So this is active low decoder. Okay, for 0011. Most significant bit is at A3 here. The least significant bit is A0 here. So 0011. 0011. Okay. Okay, now look at this question here. Assume the output of the decoder shown is a logic 1. So what are the inputs of the decoder? What are the inputs so that you get output equal to 1? Akasha. What is the output? The input, sorry.
The input.
What is the input, Akasha?
0,
Sorry?
0, 1, 0, 1.
0101. The most significant bit is here.
0, 1.
Ha.
The most
A3 is the most significant bit. So what is the input? A3 must equal to
1.
A2.
Oh, 1, 0,
A1.
1,
A0.
0,
Okay. So you must have a 1 0 1
1, 0,
0.
0, 1, 0, 1, 0.
1 0 1 0. So you get 1 at the output here. Okay, you can see the answer there. Okay, so IC decoders have multiple outputs to decode any combination of inputs. For example, the binary to decimal decoder shown here has 16 outputs, one for each combination of binary inputs. Okay, so you know this is active high or active low output. This IC. Wan Adeline, mana Wan Adeline ada?
Ada doktor.
Active high or active low output?
Active low.
Okay, so this is active low because you have bubble here, right? Okay, similar to the previous circuit where you have the output bubble there, NAND gate. So this is active low. Okay, for the input shown, what is the output? You have there 1 0 1 1. So what is the output? Look at the IC. IC is binary to decimal. So the binary is 1011. So what is the number in decimal?
11.
Equal to
11.
11. So 11 here will be 1 or 0?
0.
Huh? 1 or 0?
0.
0.
Active low. So it should be 1. 0. Sorry. 11 should be 0. The rest will be 1 because this is active low. Okay. If you don't have this bubble, the 11 will be 1. So the rest will be 0. Okay tak? Faham tak? Do you understand? Yes, yes. Okay, because this is active low, so will be low. Low meaning 0. So 11 here is, okay, 1011 is equal to 11, so 11 will be low. Let's say you have 1000. So what is the output here? If the binary is 1000.
8 output 0. The rest is 1.
8 equal to, it's not 1 8 because more significant bit is 3. A3 here, so 1000. So 8 will be low or 8 will be 0, the rest will be 1. Okay, now decoder here, specific, this one you see here, you have 16 bit here. Okay, so specific integrated circuit decoder is 74HC154. That is 4 to 16 decoder. It includes 2 active low chip select lines which must be at the active level to enable the outputs. It must be inactive here. So these lines can be used to expand the decoder to larger inputs. So this you need to use, let's say this is for 16 bit. You want to design for 32 bits. So you use another IC, one more IC here. So you use this. This will be used to connect to the other IC. Okay, that's why you have this. And then here is BCD to decimal decoder. Just now you see what? Binary to decimal. Now this is BCD to decimal. Okay, accept a binary coded decimal input and activate one of 10 possible decimal digit indications. Okay, and then you see here A3 is the most significant bit, A0 here is the least significant bit. So this is active low or active high output?
Active low.
Active low. So this is active low output, yeah. Okay, now assume the inputs to the 74HC42 decoder are sequence 0, 1, 0, 1. So, or the next one is 0, 1, 1, 0 and then 0, 0, 1, 1 and 0, 0, 1, 0. Describe the output. So now look at 0, 1, 0, 1. 0, 1, 0, 1. What is the output? What is the output? Amirul. Amirul Hakim ke? Apa nama dia? Ada tak dalam kelas ni? Nama Amirul ada tak? Saya rasa macam ada je. 0101. So what is the output here? Five will be 0. The rest will be 1. Okay. 0110. 0110. What is the output?
6.
6 will
6 will be
be
what?
0.
0.
6 will be 0. The rest will be
The rest
1.
will be 1.
Okay. 0011.
0.
3.
3 will be 0.
0.
The rest will be 1.
Yeah.
Okay. 0010.
2.
2.
Okay. All lines are high except for the one active output which is low. So the active output are just now 5, 6, 3 and 2. Okay. So this number in order, I cannot simultaneously. Is first one is okay 5, then 6 and then 3. Okay. Okay, now binary decoder driver. Okay, this is important when you want to design, you connect to the LED yang ada 7 segment LED. Okay, so you need to use this. Another useful decoder is the 7447. This is a BCD to 7 segment display with active low outputs. So this is active low outputs. Okay, now this is the input. This is BCD, BCD inputs. And then you have this connect. You need to check with the specification sheet whether where to connect this. Okay, and then this is all the same. And then this is the output. This is active low output. Yeah. This one 7447. This IC. This ni. Ini ke? This or the pin number. That's why I said just now, you need to check the spec for this IC. Okay, different manufacturer, they have different, this thing, what is this? This is read, blanking input, something like that. You need to check where to connect this. Where to connect this? Is it go to low or this connect to high? You need to check. Okay. Different manufacturer, different. Okay, the A to G outputs are designed for much higher current than most devices. Hence, the word driver in the name. So that's why it's called. It's known as a BCD driver. Please don't forget to take your attendance. Okay, now this is BCD decoder driver. Here the 7447A is connected to LED, the 7 segment 7 segment LED display. Notice the current limiting resistors required to prevent overriding the LED display. So you need to have resistor. Okay, so because you don't want to burn this LED. Okay, and then okay, BCD driver here, this features leading zero suppression, okay, which blanks unnecessary leading zeros but keeps significant zero as illustrated here. Okay, this one you can read on your own how to design with the blank here. Ada there is significant apa ni? The point. Okay, Z0. Okay, this is on to design. This also decimal point here. How this is read. Okay, so on. Encoder. Okay, just now decoder. Now we look at encoder. An encoder accepts an active logic level on one of its input and convert it to a coded output, such as BCD or binary. The decimal to BCD is an encoder with an input for each of the 10 decimal digits and 4 outputs that represent the BCD code for the active digit. The basic logic diagram is shown. Okay, you see here, just now encoder you use what type of gate? Still remember? There is no zero. Okay, here there is no zero input because the outputs are all low when the input is 0. Remember just now what gate for designing the decoder? What gate do you use? I mean for the circuit. Pergi klinik. Ada kelas di sana. Okay, so what gate just now for decoder?
AND gate.
AND gate.
Huh?
The AND gate.
Just exclusive OR, right? No, exclusive no and AND gate. Is that correct? Nurul Adlina. Decoder just now.
Yes.
What gate?
And gate dengan
AND gate and what? Exclusive NOR gate, right?
you
Ada tak?
that exclusive NOR
And
and exclusive NOR gate.
exclusive NOR gate and AND gate, right?
And gate.
Okay, for encoders only OR gate here. Okay, now show how the decimal to BCD encoder converts the decimal number 3 into a BCD 0011. So now look at here. Okay, no. The top input, the top two OR gates different ni, kenapa ni? Okay, indicate the red line. Okay. Okay, now you want to design decimal number 3. And then you want to get what? In the BCD is 0011 because this equivalent to 3. So 3 is equal to 1 here for the input. The rest will be 0. So you see the red here, the red wire here, the top two OR gates. Okay. Ones are indicated with the red line. So because OR, remember, if one of the input is 1, so you get the output 1. So here is connected, here you get 0011. So this is how to design encoder. Okay, that is using the gates. Now you see the IC. The IC for encoder is 74147. Is an example of IC encoder. Okay, you have 10 active low input. See here, you have bubble. So this is all active low input and also active low output. Okay, so the output is in BCD. And then here is the decimal input. Okay, if let's say 3 is the input, so you will have here the output equal to what? So the input will be here 0, and then because it become 1 here, so 3 meaning 0, 0, 0, 1, 1 with 1, 1 here will be 0, the rest will be. Macam mana? So what is the input, what is the output? Hello, are you sleeping? Senyap je. So this device offers additional flexibility in that it is a priority, equal priority encoder. This means that if more than one input is active, the one with the highest order decimal digit will be active. Okay, if you have simultaneously, then only the highest order will be active. So this is the priority encoder. Okay, you see the next slide here. Okay, this is designing the keypad. Remember keyboard or keypad normally. You have here number from 0 until 7. This is for 8 bits. Okay, connect to here. Not 7. Wait, 1, 2, 3, or 9. Sorry, I thought 7, 9. This is for the digit from 0 until 9. You have 10 here. And then you get the BCD here. So the 0 line is not needed by the encoder but may be used by other circuit to detect the key press. Okay, so this is how you design circuit using the button. For example, the key in your telephone. But now all touch screen. This is how this is connected to the encoder, and then you get what is the output here. Okay, any more question? Do you have any question? Ni. Ni. Ni bukan, ni BCD. Ni different. This is decoder. This is decoder. Decoder, if you see here, decoder is from one input, you have many output. You see here, this is decoder. Decoder. If encoder, you see, you have many inputs, one output actually. Okay? Okay. That is the difference between encoder and decoder. Okay, you see here. Okay. This is simple on
Hey
YouTube.
everyone, so this video is going to be about encoders and decoders and try to make it as quick as possible because it takes once again I'll be like 10 minutes long and stuff when it really doesn't need to be. So let's get started here. An encoder, basic idea behind an encoder is that it will take multiple inputs, as you see here, and we'll turn it into only a few outputs. Let's see here. Decoder is the same thing, except that it does the opposite. So we'll take very few inputs and we'll turn it into multiple outputs. So the way that we find out how many I variables or j variables there are with the number of x, y, z variable type things that we have. So if we have x, y, and z, that means that we have 3 variables coming out here. What's 2 power 3? It's 8. So in terms of an encoder, if we have 3 outputs here, then we're going to have 8 inputs. And for the decoder, if we have 3 inputs, then we'll have 8 outputs. So I'm going to cut out for a second while I put some truth tables, fill them in together. Okay, so this is the truth table for an encoder. So it's kind of similar to a multiplexer, and then we're still kind of dealing with cases for conditions. So when x, y, and z, oh crap, I'm still getting used to one though. I have no idea what's happening half the time. When x, y, and z are all 0, that means that our input will be our very first input, just because this is the first and the condition of x, y, and z. So that will be 1. And we're just going to iterate all the way down. It's going to kind of form like a bit of a diagonal type thing. So I'm going to fill in some zeros. So that is 0, 0, 0, 0, 0. So you're only going to have one value on each row of inputs. Right, so now we're on our second condition.
Hello, are you still there?
So another way of saying it
Semua
is
ada
that
dekat depan komputer awak lagi ke?
Ada.
Ada.
Yes, doktor.
Okay, saya bagi laju saya nak tunjukkan macam mana apa tulis dia
and we're just iterating down. We're honestly with this just a table for an encoder. Right here.
Okay, if you look at here,
Is 1.
Wait.
And
Wait.
I just refer decoders are 0, 0 for x, y, z, and then we just kind of go down.
okay, if you look at here, encoder, okay, there are many inputs here. It goes to meaning encode. You encode. You have the data and then you code into code. For example, you don't want people to know what you sending, so you encode it. You give a sign, a form of only you know. Okay, that is encoder. Okay, so you have the input here mini, so you encode this. Okay, so the encoder is only for 3 bits here, X, Y, Z. So if, let's say if the I naught here is 1, so this equal to what? 0, 0, 1. If if I naught is 1, so it becomes 0, 0, 0. Okay, if I1 is 1, so meaning this is 0, 0, 1 and so on until the 7. 7 meaning is 1, 1, 1. Okay, that is for encode. So you can only send one input here, okay, at one time. That's why you only have either one this here, either one here, either one here, that to show you. Okay, you can only send one. Just now, you see encoder, priority encoder. If you send 2 number at the same time, it will take the highest order. That is for priority. Okay, faham tak?
So now we're going to look at decoders.
Okay, because it's almost 4 o'clock. You may have class.
We're just really looking at
Okay.
x, y, z. So 1, x, y, z are all 0. Our first output will come out. I actually forgot to label this as being j. So these are all j values.
Okay, because here he use J here, so it changed. This will be changed here because it use J here. Okay, now the input for decoder, decode, meaning you send just now, you encode, and then you want to retrieve the signal just now, you decode, meaning you have the data just now in the form of code, which you do not know, okay? So now you need to decode it back to get the original data. So that's why you need to use decoder. So normally you use encoder and decoder in pair. Okay, you encode the signal, okay, in a specific form that only you know, okay, and then you decode to get the original back, the original data back. So here, this is XYZ, meaning this is the code you you input into the IC here, okay, and then you get the output. So for example here, XYZ is 000, so this is equivalent to J not equal to 0. For example here, if let's say XYZ is 011, so 011 is equivalent to what? This is 3, so I3 equal to 1, and so on. Faham tak?
Doesn't really matter.
Okay. Okay, so I just show this YouTube because to show you the difference between encoder and decoder.
I wanted to
Okay.
differ.
Okay, do you have any more question? Do you have any question to ask?
0, 1 or second go out. It's just based on conditions. So again, we just need to count the list here. So we go from first condition. So we go 1, first condition to a second, or third, or fourth, or fifth, or sixth, seventh, or eighth. And we're just following the backwards again. So I hope that was helpful. That's pretty much it.
Okay, do you have any more question?
No, doctor.
Aiman Iqbal, do you have any question?
No, doctor. All okay.
Okay. Okay, if you don't have any more questions, see you next week. Okay, and also
Alright.
study for your test, yeah?
Okay. Thank
Okay,
you,
your
doctor.
test, make sure you study. Make sure you study for your test. If you want to ask me anything, you can ask, eh? Apa dia? Kita dah buat? I can't hear you. Ha? Tak ada. No objective. Subjective only. We don't have objective. Normally 1.5 hour, but you know, with that time, I think you don't have enough time to upload everything. So normally I give enough time for you to upload your answers into the Putra Blast. So normally it's 1.5 hour, and then plus lah. Okay, so study on the numbering, convert the number. Make sure you show all the working, not just give the answer. Okay, if give the answer, you don't get full marks. Okay. Hah? Apa dia tak faham? Ha? From which topic is from the first day of class until I think before the adder. Normally adder is not included, but I will find out from Puan Susiza because she's the one who set the question, not me. Okay, so maybe you want to ask your friends in the other class what Puan Susiza teach them. I don't know. Maybe because she set the question, maybe she has more, you know, hint or whatsoever. Okay, any more question?
Doctor, may I know the date of the test?
Hiya! Friday! Friday is what? 30th?
Alright. Thank you, doctor.
Okay. Okay, bye.
Alright, Baik Doktor. Thank you so much.
Hmm.
Terima kasih doktor. Selamat buka.
Thank you, doktor. Selamat buka.
Okay.
Selamat iftar.
Okay.
Terima kasih
Semalam sempat beli tak
doktor.
hujan tak awak? Semalam sempat beli buka tak semalam? Ke hujan?
Oh, sempat Doktor.